Let's prove this by mathematical induction. First, we write our proof and by mathematical induction. First thing we need to do is let Pn be the given equation. Next, we verify. Do the verification. Do we need to verify if the left-hand side of this equation is equal to the right-hand side? We'll know that it is true. Let's let n equals 1. It's the minimum value here. So the left-hand side of P1 would be summation which is equal to, replacing I, we have 1 times 2 times 3 and get 6. Now for the right hand side of P1, we have n times n plus 1 times n plus 2 times n plus 3 over 4. Replacing n with 1, we get 1 plus 2, that's 1 plus 3, all over 4. Simplifying, we get it's 2, 3, 4 over 4. Cancel out the 4s and get 6. So P1 is true. Okay, we do part 2. Part 2 is we need to show that pk implies pk plus 1 is true. Now to do that, first we assume pk is true. Kind of looks weird. True. That is, replacing n with k, we get, we need to show that pk plus 1, which is the summation k plus 1 equals k plus 1 times k plus 1 plus 1 k plus 2, oh, that's k plus 1 plus 2 and k plus 1 plus 3 all over 4. From this we have to, so you can see, from this we have to arrive at this equation. So starting here, now let's start here, summation. How do we get from this to this? We have to add something to it, which is the second term. That if we assume that k is 1 and k plus 1 is 2, then all the values here would just be added by 1. That's I plus 1, this would be I plus 1 plus 1, I plus 1 plus 2. Since 1 would be here, here would be 2, k plus 1. That's like 1 plus 1, or I plus 1. Okay. I guess I have to erase. Okay. We have to add, instead of I, we add k. since it's up to k. K plus 1, k plus 1 plus 1, and then k plus 1 plus 2 would be equal to k times k plus 1 times k plus 2 times k plus 3 all over 4. But since we added this to the left hand side, we'd have to add it to the right hand side as well. That's plus. We could just write this as k plus 2 and k plus 3. There we go. And so this would become simplified to this. We will have summation from I to k plus 1. So we can see that we have achieved it in the left hand side. Now we just have to simplify this to make it look like this. Simplify this to make it look like this, which is equal to, since there are the same terms, k plus 1, k plus 2, and k plus 3, we can factor them out. K plus 3, which would leave k over 4. It's k over 4 plus 1. Do you get that from factoring, right? Since it's like 2k, let's say 2k plus k. If we wanted to factor k out, that would be 2 plus 1. That's what we did here. Okay. So now how do we simplify this? We could make 1 into 4 over 4. So that they'd have the same denominator. We could have k plus 4. See, we have this k plus 4. We write that down, k plus 1 times k plus 2 times k plus 3. And here, what was it? It was k plus 4 over 4. And since, for example, we have 2 times 3 times 1/4, that would be just like 2 times 3 times 1 over 4. That's what we'll do here. Basically, we have achieved it. K plus 1, k plus 2, k plus 3, and k plus 4 over 4. If we wanted it to look exactly like this from this, we could just separate. Instead of k plus 2, we would do k plus 1 plus 1. 1 plus 1 is 2. And k plus 1 plus 2, k plus 1 plus 3, all over 4. So it looks exactly like that. So we have shown that this became this. We can now say that therefore pk plus 1 is true. And on to the last third, we have our conclusion, which is by PMI, proof by mathematical induction, the original equation, write it down, n plus 3 over 4 is true for all n greater than or equal to 1.